Okay, so the first thing we're going to talk about here in Unit 1 are motion diagrams. So this is a little bit than probably you may have learned this back in AP Physics 1. Okay, but this is just going to be a little bit new focus. So again, motion is defined as the change of an object's position with time. So this is the important kind of idea, right? Basically, position is where an object is placed. So in this unit, we're just going to think about where an object is placed in terms of a number line in math class. Now, there's going to be four basic types of motion. They're going to be linear motion, circular motion, projectile motion, and rotational motion. So these three are what we call translational. Now, sometimes these two look very similar, but they're actually going to look a little bit different. And there'll be pictures here in a second, and we can look at the difference between the two. Now, what we're going to look at in a lot for the first couple of videos is we're going to study motion diagrams. And motion diagrams are just simply showing an object's position at severally equally spaced instants of time. Basically, what motion diagrams do is that they allow us to see what when an object speeds up, slows down, or maintains constant speed. Okay, and we put C in quotation because you can see this is like a frame by frame uh, picture of the motion, but we're going to combine it all into a single frame, okay, so that we can see what's happening. So constant speed, you'll see that the intervals are basically evenly spaced. So the distance from here to here is the same, from here to here is the same, from here to here is the same. When it is going to speed up, it's going to get larger. So this distance is going to be smaller than this distance, which is going to be smaller than that distance. And then the last one slows down, it's going to be the opposite. Right? This distance will be less than this distance, or excuse me, greater than the previous distance, and so forth. Now, just again, the four types of motion, right? We focus on linear speed, so straight line or linear motion is straight line motion. Or circular motion is when objects rotate about, right? They essentially revolve about an axis. Okay. Projectile motion, all right? So this would be like shooting a basketball, kicking a soccer ball, kicking a football. Um, and you'll see that there's going to be different instances of that. And then finally, rotational motion, which means the object rotates about a center of mass. And so those are our four types of motion. Now, here's a quick example. All right, this would be kind of a um, this would be, kind of, you should see it's a justify your answer type question. So which of the following cars is traveling the fastest? And justify your answer. That's very important on the AP physics test, is justification of answers. You can't just say it is because it is, right? You have to explain it. You can show formulas. But here this would be an explanation one. We're going to assume that that there's equal time intervals between the frames of both videos. Right. And so this should be a good time to pause the video and answer this yourself and then start it once you're ready to go. Okay, so now let's talk about the answer. So the answer to this question, which one is traveling the fastest, is actually going to be car B, right? If these are equal time intervals, right? Note, or I should be pointing out the front end of the car, but note that there's a shorter distance, really, right, between the frames of the video. Okay, so that means that this car, right, car B is traveling a greater distance in the same time interval. So if we say speed, not position, so speed is distance over time, larger distances in shorter time mean larger speeds. Okay. Now, if we want to talk about um, the opposite, right? So these are inverse. So shorter distance, if you want to say in the same amount of time, would produce a shorter speed. So the green would be car A and the red would be car B. So car B It's traveling the fastest. Why? Right? Again, our justification. It is traveling a shorter distance, or not shorter distance. I apologize. That should be uh, a longer distance. So it's traveling a longer distance in a in the same time. Okay. So that's the start of talking about motion diagrams.